All right, awesome. It's great to be here. My name is Raúl Kripalani, and I'm going to be talking about FVM. FVM as a technology. Where is it going? That's the name of the talk. So we're going to be focusing mostly on the future, but I'll give you like a few touches as well on the past. The goal for this talk is really to give you a high-level contour of the protocol developments that might be coming down the pike. And this is non-comprehensive. There's a lot that is still in flux. There's very little time for this talk, so I won't go into too much detail. My goal here is to give you kind of like the high-level overview of everything that I know personally that is in the FVM pipeline, but there might be more things out there because there's a number of teams that are working on developments for the FVM. Now, one more thing that I wanted to say is that this is part one, as Jennifer said as well, of a track of the protocol development track as well that's going to run in Iceland. And there's going to be great talks and great workshop sessions and so on by Steb, who's also a key contributor to the FVM. And he'll go into a ton more technical detail there. So like my goal here is to get the discussion started by giving you kind of like a high level contour, right? And of course, like I would love to give you to get to discuss all of these items with you. Cool. So just to give you kind of like a little bit of where we've been, a little bit of a look back to the past and kind of like the present, as you know, FVM shipped on Pi Day 2023. That's going to be 6 months on September the 14th. So we're actually, the day that this event ends is the 6-month anniversary of FVM. So I think we should do something. I'll just leave it up to you there, Jennifer. And since then, we've had 9.5 million just kind of like to give you some stats, 9.5 million fill in deposits, 8 million fill in borrows. There are currently 700K accounts and placeholders in the network, which is amazing. There are around 2,000 unique contracts and thousands of builders pouring into the ecosystem. Now, I was kind of like going through all of the protocol and FVM development opportunities and kind of like the pipeline. And I was like trying to figure out, well, how do I present this? How do I present the high level overview, right? Like a linear list would be too boring. So this is kind of like, I came up with this diagram. It's a stacked roadmap. And it's kind of like a mental model of how I'm personally thinking about the different categories of protocol development that are in the FVM pipeline. The fact that something is here is not a commitment that like it's actually going to be built. This is the point of this event, to like gather feedback, really discuss with you on like what is really important to develop for the FVM and get those conversations started. So this is a disclaimer. This is my own mental model of what lies ahead. I'm going to walk you through it. So on the bottom layer, there is the foundational work that is ongoing, which I'll talk a little bit about in the next slide. Then on top of that foundational work, there is the user-deployed compiled Wasm actors that build on top of the foundational work. But there is also kind of like a parallel stream there, which is potentially adding support for Wasm actors by introducing a Wasam Interpreter. So I'll also touch into this and why that might be very interesting. Now, on top of the user-deployed Wasm actors, there are a number of opportunities that become unlocked once that capability ships on top of the FVM. So we've got user-deployed runtimes, programmability enhancements. We've got new protocol features, and something that personally, it's very near and dear to me, and I don't think we've talked a lot about yet, and that is storage and state integration. We usually think about compute over state. FVM is compute over state, and then there is compute over data that operates on the data on the Filecoin network. But what if we're able to somehow merge these two, for a subset of potential data blobs that might be stored on the Filecoin network. So I'll touch on that. And then on top of the programmability enhancements and new protocol features, you've got what I call the Fem OS Foundations. Alfonso already touched on FVM OS. What is that? I'll go into that. And then the yellow runtime, quote unquote, that would be built on top of those foundations. So let's start with the foundational work. The original intention, our original intention was actually to ship Wasm actors, Wasm programmability first, but we found that Web3 devs wanted to a very quick entry into Filecoin and wanted to get started building for Filecoin without having to like relearn new tools and new APIs and so on. And like they wanted to be able to port existing contracts into Filecoin as is. So we flipped the order around and we prioritized shipping the EVM runtime to the network. So things like, for example, the Filecoin EVM and the Ethereum, the Ethereum account were shipped as built-in actors. And it was a great win because we amassed a thriving builder community. But we deliberately took kind of like some shortcuts to be able to ship this quickly. And now we're getting to address all the foundational work that we were able to stash. And those are things like, for example, the IPLD reachability analysis and scoping, which is really important for the security model. When you deploy a new Wasm actor, you want to be able to, you want to guarantee that that actor can only access state that it's written and nothing else in the system, right? So it's kind of like the sandboxing model at the data level is getting built now. We're also adjusting the signature of several syscalls, partly shipping in NV21, but there's going to be more changes down the line. And we're also adjusting system limits. So this is kind of like, going back for a second, this is the foundational work that's ongoing at the base of kind of like the stacked roadmap, right? Next step would be on top of that foundational work, now that we've hardened the system and it's secure and hardened enough to run arbitrary user deployed actors, we would be shipping, we're working on shipping user deployed Wasm actors. And these are the compiled version. There is also the interpreted version that I'll go into in a second. And the theory and the context here is that developers want to build Filecoin actors in Wasm compatible languages. They don't want to be constrained only to Solidity. So things like Rust, AssemblyScript, TinyGo, which by the way, there are already initial SDKs for these that we built, that we kind of like got the community to build 1.5 years ago. So it's kind of like already prototypes for these SDKs. And this would allow them to optimize gas costs, and it would allow them to optimize as well would allow them to obtain access to low-level Filecoin primitives, like, for example, IPLD, data exchange between actors, and things like that. And I'll talk about this a little bit more in the next layers of the stack. So what does this actually mean? By the way, I didn't say it at the beginning, but each of these layers of the stack, as I'm going into it, has a context and details, right? So you'll see that little code. I'm going to talk about why this is important and then go into details. Now, for user-deployed Wasm actors, this is a very complex topic, right? Like getting this right, it's super complex. The first branch of complexity here is the actor code installation and everything that goes along with it. So when a user submits Wasm bytecode to the network, that bytecode first of all needs to be assembled because Wasm programs are usually larger than other kinds of programs that may run in the network. So submitting code for it to run on the network might consist of packaging that code in several messages and submitting them in sequence so that they can be assembled, right? So that is the first step of complexity. Second, it's validation, making sure that the Wasm code is structurally correct, that is using primitives that are allowed and nothing that is like forbidden, quote unquote, like things like float that might be non-deterministic stuff. So that's another step. The most complex one is actually bytecode compilation because this is entirely platform dependent. Wasm gets executed normally by taking Wasm bytecode and compiling it to native machine code. And that step is actually usually non-deterministic, right? There are things like single pass compilers, for example, that will not go over the bytecode over and over again up to like a limited extent. And other networks, like for example, Near are using that. We're looking into that. We're using the Wasm time runtime. Currently, Wasm time does not support single pass compilers, so we kind of like a little bit gated on that. And that's why I'm going to talk about Wasm interpreters in a second. All right. So now the next thing is that now that you've got this compilation step, the network actually needs to agree on the cost of that compilation step, on the effort, and the gas attributed to it. And because compilation is platform dependent, this is a very hard problem to solve. All right. So another branch of complexity here is runtime interop. So the key mental model of the FVM is this hypervisor model in which you can run programs of many types that are sitting on top of these runtimes, and they're able to seamlessly interact with one another without the user having to like think about them like exponential complexity of, well, there's a program here that needs to talk to this kind of program, this program, and I need to like build a primitive. So you don't want one-to-one translation, right? You want the platform to do that for you. And that is where like it gets hard. You need to agree on call conventions and like create really, really stable ones that are able to accommodate all the variety of runtimes down the line, right? Interface specifications and a lot more. Another branch of complexity there is the syscall API. We need to stabilize it, and it needs to be versioned because systems change and things will change over time. And we need to provide also elegant upgrade paths so that when an actor deployed against a particular version of a particular runtime can be migrated to a higher version, right? And things are not going to like kind of like be rug pulled under them and suddenly support is gone out of, like it ceases for a particular runtime, right? And then we have everything that is on the right? So this is developer, when you build, like when we're creating the ability to deploy Wasm actors in the network means having to think about the developer experience, things like SDKs, explorers, RPCs, libraries, testing tools, debugging. This is an entire new development experience on Filecoin, right? So it's like we get to define it, it's great. We get to define that developer experience, but it's a lot of work. It's a mountain of work. Things like user experience, wallets, basic apps, building blocks, all of these, we need to think about those. Now, can somebody tell me, and there's also kind of like the auditing know-how and docs and so on. Can somebody tell me here what that box might represent, that bounding box? Maybe? Anybody else? Yeah? You're not building it. We didn't have to build it. Yeah. This is the stuff that we were able to inherit from the Ethereum ecosystem that allowed us to ship FVM relatively quickly, right? And this is why at the beginning of this talk, I said we reprioritize and we flip the order because we were able to inherit all of this so that people, many builders that are today in this room could get started building for Filecoin as quickly as possible, right? So just wanted to give you kind of like that overview. Now going into back to the stacked roadmap, I'm gonna go into the Wasam Interpreter, right? So I just talked about all the complexities of actually shipping compiled Wasm code, right? Now, what if we, instead of like a lot of that complexity was actually related to the compilation process and everything that needs to happen, right? What if we shipped a new runtime that was actually a Wasm interpreter? Some blockchains actually stop there, right? Like other chains literally just do Wasm interpretation, right? Now, what does this actually mean? It means, like, as I said, shipping a new built-in runtime. Maybe we can call it Wasmint. Nice, there's like a little color as well, mint color, so we might have like some visual stuff there. This is essentially Wasm in Wasm. So Wasm interpretation is running inside Wasm. Could be based. There are Wasm interpreters that we could just adopt, and these are prepared. Like for example, the parity one is prepared to run inside Wasm. So we could just prototype that and see how it works. And we would like literally advertise this as inefficient. But what's the point? It allows developers to start experimenting with the developer experience of Wasm actors before we figure out like a lot of these complexity points, right? Now, how does this compare to like shipping the whole shebang, right? We're basically able to remove these yellow stricken out things, points of complexity, right? But everything else still remains. So if we like prioritize, and this is, I think, some signal that the FVM team is trying to gather, it's like, do we as a community want to prioritize shipping Wasm capabilities to the network as soon as possible because developers really want them, and what does it unlock for them right now? So this is kind of like one of the signals that we're trying to get from this. Yep.
Is there another Wasm runtime that it looks really good that has a bunch of that?
So there is Wasmer. We looked at that has a bunch of this. Oh, that's an interesting question. I think we probably, you mean the bounding box, right? Yeah. Yeah. No, I mean, like it would be like we would be inheriting the chain experience of like another chain. So we can look at it and figure it out, maybe, because yeah, I think this is also an opportunity to kind of like really we as a community getting to define what the developer experience on Filecoin is going to look like, and for us to be visionaries about what and opinionated about what we think the blockchain world actually needs in terms of developer experience, and not letting others define us. I think it's also that, but that comes at a cost, right? It's significant effort. Yeah, Wally.
Yeah, so similar to Juan's question, which was, hey, are there existing blockchain runtimes that support Wasm or compiled Wasm contracts, but also have built-in Wasm support for SDKs, RPCs, wallets, et cetera, that would be smart to add in order to support the same set of developers that would want to be not writing in Solidity, but writing in other languages.
Yeah.
But where this set of significant developer tooling wouldn't need to be constructed from scratch, but could be borrowed from another ecosystem, maybe Solana, because they notably talk a lot about
so I would
it.
imagine, for example, like the stuff that we could potentially think about inheriting is everything in the building blocks block, which is, well, are they like really good primitives, like for example, tokens, dexes, bridges, standards that already exist in other Wasm ecosystems that like we could minimally somehow adapt like the code of those primitives to like run with the Filecoin APIs. You still need to do work, because at the end of the day, it's like these actors would be calling into the Filecoin APIs, right? So if we do that, it looks a lot more like bringing in the runtime of an existing blockchain, similar to like, the EVM, because we decidedly as a community support or really want to like pull in a new fresh batch of developers that like, have built really cool stuff for another ecosystem, and we want it to be portable. So it would look like the runtime of another chain more than like us cloning or like copying parts of that runtime for our native, not native, but Wasm runtime. Yeah.
I guess the interesting question would be, do any of those other networks or runtimes support precompiles the way that EVM supported precompiles for us to add in access to those Filecoin actors?
Yeah. Yeah.
Couple
by the way, can I go over by 10 or 15 minutes? Because like I agree that we like the questions are great, but I have a lot more slides.
Quick question, and feel free to dismiss it. My sense is that the experience of those things in the bounding box are going to look very different in the yellow runtime IPC multi-chain world.
Yeah.
And so instead of like doing it once for the single chain world and then again for the multi-chain world, I would defer it until that point, and then I would maybe look around at which Wasm bounding boxes, which Wasm runtimes from other chains have the largest number of developers, and bring those in. Yeah, yeah, I agree with that. Like things like, for example, SDKs and explorers and RPCs are going to look very different, and specifically the testing tools and debugging. And let's move on. Let's continue. Let's save questions for later. Okay. Anyway, just recapping. At the bottom are things that we've talked about, and we're going to continue talking about the things that are still colored. So we said that in this diagram, user-deployed Wasm actors, getting that and building that gives us the ability to deploy new items on the roadmap. So those would be user-deployed runtimes, programmability enhancements, new protocol features, storage state integration. I'm going to talk about each one of those. So for user-deployed runtimes, the context is FVM, we know, is built on a hypervisor architecture, which is using Wasm bytecode as its low-level execution format. And the AVM was the first runtime that we deployed. But what we expect is that when user programmability on Wasm ships, we will see developers building and deploying their own runtimes in a completely permissionless way. Like there's no fib required, they'll just go in and deploy the runtime. Now this will bring, the benefits of this is that it will bring program diversity to Filecoin, increasing the general utility of Filecoin as a blockchain to Web3, right? So if this Filecoin becomes this ecosystem where programs that already exist in other ecosystems can seamlessly run on top of Filecoin, and they can interact with other things, then that accrues more value for Filecoin in terms of the value that it's and the utility that it's providing to the ecosystem. Also, these programs, and this is like one of the main selling points of Filecoin, is they eventually can get access to off-chain or even on-chain storage
right? That is super cheap and potentially even like on-chain storage provided by specialized IPC networks that do things like data availability and stuff like that. So like, those programs can get access to that eventually when those capabilities ship. We already have a number of groups that want to ship their own custom runtimes. People like, for example, Fluence, Tableland, and so on have been waiting for this. There are other potential runtimes like Lurk for ZK proofs, Move, Solana, eBPF, like a number of things that we can that would be useful to or interesting to ship as runtimes. Now, one caveat here is that it might require like shipping a runtime for it to be like fully complete might require things like extensible addressing, account abstraction, and new syscalls, right? So the first two, extensible addressing and account abstraction, are things that I'm going to be talking about in not this slide, but the next one. Okay, yeah, give me, can I go over by 5 minutes?
You're already over by 7.
No, that's not true. Okay, thank you. All right, so in terms of programmability enhancements, which is another thing that Wasm actors give us, when you control the developer experience and you control like entirely the environment that's available to an actor, you can provide new primitives and new programming primitives to those workloads. So you can start doing things like, for example, IPLD tricks. Like, you can pass entire subgraphs from one actor to another by simply passing the CID, and like that action will automatically put the entire subgraph in scope of that other actor, which is something that you can't do today. You can do async programming, callbacks, continuations, and stuff like that. You can do volatile state across calls. I don't think we've really explored this, but this is the ability, once you marry it with like asynchronous programming, you say, okay, an actor receives a call, it doesn't await at a point in time, and it kind of like stashes a state into something that is not the state tree, for example, and it's just like a memory buffer, so that when the continuation resolves, it's able to like access that state in a hot way very quickly and very cheaply, right? Things like that, carryover state. You can offer scheduled tasks, things like what we've been calling user-defined cron jobs, event subscriptions, so actors that subscribe to the events emitted from other actors on chain. You can do capability orientation and this is like where UCANs come into the picture potentially at an actor level to like really create stricter security models. You can do multi-calls and delegated executions. This is like, defining the development, I think innovation and programmability innovation that Filecoin could potentially provide to the world, right? Now, shipping Wasm actors also allows us to start shipping new protocol features as well. So once we ship the actor once we control the entire actor runtime, we can start exposing new protocol features to Wasm actors without jumping through hoops. We can technically do that today as well if we like expose EVM precompiles and like special function selectors for inbound calls and stuff like that, but that gets rough. So things like, for example, shipping account abstraction, like it's probably going to be more useful if we ship Wasm actors first, right? Things like, for example, actor upgrades, right? And being able to upgrade the backing code of an actor by another actor without changing its addresses on chain, right? That's super useful. And like being able to carry out a state migration at that point for that actor. User deployable extensible addressing. So imagine everybody here is likely familiar with the F4 address class, right? So imagine being able, and F410 stands for the namespace, the sub-namespace that is addressed by actor number 10 on the chain, which is the Ethereum address manager, right? So imagine being able to ship users and developers being able to ship F for 11, 12, 13, 14, 15 with like your entire like user-defined naming scheme and addressing scheme for actors, right? So that's another protocol feature. And then this one is very interesting. Storage and state integration. We've traditionally been segregating storage from state. And we say FVM provides compute over state in the Filecoin chain. And then COD networks, L2 networks, would provide compute over data over the data that is stored in the Filecoin network, right? But that creates a chasm in the vision of like Filecoin as this unified computer, right? Because like now you have all this wealth of data that is stored there and you can't really access it from programs running. Like even if you're trying to compute over a tiny blob, say 1K, that's perfectly feasible to do on a chain, right? On chain. But if you have to resort to COD networks just for that tiny computation, it like overcomplicates the whole picture. So what if we leverage async programming primitives to like, so here's a flow, I think Juan likes it. So imagine that a program requires that an offloaded piece of data that is sitting somewhere in the network, it requires it to operate on it and is referred to by CID. So it emits like some kind of native event, like a load event, and then it waits, right? And then some storage provider which has this piece of data, and by the way, they're using Boost, so they have the local indexer and they can find it really easily, right? It just addresses into that piece of data and then presents it on chain and earns a tiny reward that is encoded in the load event, so they know ahead of time how much they're earning, and then the contract also refunds the gas, right? Because like it's brought utility to the contract. Now the await is satisfied, and the program can continue processing with that piece of data, right? And then there is output that needs to be saved, right? So you do like the reverse process, right? So you emit a store event, and then like the moment that somebody posts a PODSI, a proof of data segment inclusion, for example, for that piece of data, to you, you reward them. And you refund gas fees. Now, good news is that this is great, but you don't have to wait for asynchronous programming primitives. I think this is like one of the hacks. If somebody is willing to hack during this, we can literally start building a prototype of this today with EVM smart contracts and PODSI. Like this is a potential hack that can come out of this, right? We don't need to wait for asynchronous primitives. Let's do it. Let's do it. Cool. All right, so just recapping, this is where we are, and I have 2 more points to cover. I'm going to go very quickly over them. So on top of the programmability enhancements and new protocol features, there are 2 things that stack over that, and that is Fem OS Foundations and the Yellow Runtime. So on Fem OS Foundations, what the key idea here is that FVM can power a lot more classes of workloads over time, right? So Yellow Runtime is like the whole client is running inside FVM, or like big chunks of the client are running inside FVM. Compute networks, ZK proofs, it's all very exciting, right? What does this imply? This implies making FVM a generalized multi-environment IPLD compute machine, right? So it's just a machine that operates on IPLD data. Of course, there are people doing this as well. So the IPVM, so Fission and the IPVM project is doing this. So they're going to be in Iceland, and I think I won't be there, but there's going to be a big brain mesh there to like figure out how to merge both roadmaps. So what are some features that we would deploy, or like we can potentially see in the sub roadmap of Fem OS Foundations? Things like, for example, support for long-lived processes. Right now, you invoke an actor, and that creates a container, and off you go. Once the actor returns, the whole thing is dissolved, right? So what about if we are able to create long-lived processes with live memory, mechanistic IPLD caching between calls, suspension, and fork and join between those things? So you really like start building OS level like processes on top of FVM. And then you marry that with process trees with support for moving between like different parts of the tree, a little bit like Erlang actors and kind of like the process hierarchy there. You can also do non-state tree related computations where all the data is either provided in band or it's actually stored in multi-stores, but not necessarily coming from a state tree, because the state tree is an abstraction that's relevant in blockchains and not in a lot of other places, right? So if you want to generalize the machine, then like maybe it's no longer needs to be married to a state tree, right? Chain processes, like the ability to chain processes together in a pipeline for streaming patterns, parallel execution, and a lot more that can go inside this. So this is really one of those cases where, like, you know, put your idea here. There's a lot that can go in here. And then finally, on top of that, we've got Yellow Runtime, which is a code name, by the way. It's like it's just a code name. And this is all about creating highly customizable blockchains defined as data. So the whole blockchain and the logic behind a blockchain and what would traditionally sit in a client that has been compiled, that has code that has been compiled and into an executable, and that's it. This is actually all moved to content address Wasm bytecode. So what does this mean? This basically leaves the client at like a really skeletal place where it's a really thin client. It's just a container, right? where it delegates most of its responsibilities to Wasm modules. And now you start seeing why, for example, long-lived processes are really important, because you don't want to be like, you want to save some state that you're tracking, because you don't want to be incurring in the overhead of starting and stopping Wasm containers every single time that something happens an event happens in the chain, right? So basically, the skeletal blockchain acts like a container. And then imagine there is a manifest, which Alfonso already presented you some key ideas about. So this is basically a manifest that tells you, okay, for consensus, you're going to be using the module that is represented by the CID. And imagine if we do networking protocols as well, or like say for the mpool logic, you're going to be using this. For networking protocol, maybe like this policy of Gossip Hub, whatever, that is like provided by this Wasm module. Imagine that so you've got this document that has a lot of references to the code that is going to be powering the blockchain, right, by CID, and then you go and upload that manifest into a content address network like Filecoin or IPFS, and you get back a single CID that represents the entire configuration of your network. And then the way that you would bootstrap into this network is by starting the skeletal client and providing that CID, right? Or like it can discover it some other way, right? It could be like a name thing because you don't want to be like managing CIDs directly, maybe. And what it would do is like go into the network, fetch that CID, fetch the manifest, start downloading all of the modules and start wiring that chain and just start it and start the process tree for that chain. And off you go. You've been able to bootstrap with a single client, single binary, into any network that has whatever consensus, whatever networking protocols, whatever mpool logic, whatever fork choice rule, whatever, with a single client. So you never need to fork any code base, right, to be able to participate as a validator, as a follower, as a light client into anything. And then you take this to kind of like the browser or the mobile space, right? And this whole thing, because it's Wasm, and guess what? Wasm was originally developed for the browser, right? So like it's browser native. If you're able to run all of this and it's backed by Wasm and the whole blockchain is defined as data, you're able to like literally run a blockchain node in a browser, and it doesn't matter which blockchain because you can just click and select, right? Or not even that. So here are some visual representations of like, for example, this is what the manifest could look like. This is the architecture, and I'm being told that I need to wrap this up. So, so yeah, the whole point of like this talk is to give you like a really broad view on everything that the FVM team, IPC team, and so on have been thinking about. As I said, like there's no strong commitments on any of this. We're looking to like, just putting a bunch of ideas out there and like really discussing them with the community. So it's just a high-level contour of what we're thinking about. And if any of this gets you excited, I hope it does, then let's discuss and figure out the best way to get you involved. And also, as I said, there'll be deeper dives in PhilDev Iceland, so make sure to go and follow there. It'll be probably a lot more technical than this. And that's all. Thank you.